Hey everyone, so I've just got my hands on the Special Exam 1. Let's see how it goes. So we want to verify that 3z plus 2i is a factor. That means that f of negative 2i on 3 should be equal to 0. So that's 3 times negative 2i cubed. I'll just write it out first. Plus 2i times negative 2i over 3 squared plus 3 times negative 2i over 3 plus 2i. Now this here, so the negative 2 cubed is negative 8 and the 3 cubed is 27 times 3 will be 9. Now the I cubed is basically I squared times I, which is negative I. So that should be negative, so that would turn into positive 8 on 9. Plus, now this here is going to be positive 4 over 9 because, sorry, it'll be negative. Because negative 2 squared is positive 4 and then I squared is negative. So minus 4 on 9 times 2i, which is minus 8i on 9. And then, what have we got? Plus, oh, that's just minus 6i on 9. Oh, wait, minus 2i, and then plus 2i, which is equal to 0. Okay? Therefore, 3z plus 2i is a factor. Alright? Hence, or otherwise, solve the equation f of z is equal to 0. So if, so be very careful that we can't use the conjugate root theorem here because this f of z does not have all real coefficients. If it did, we could say that 3z minus 2i is also a factor, but we can't do that here. So what we have to do is we have to do some long division. We know that 3z plus 2i and then something else, which is a quadratic, is going to be able to be to help us factorize this. So what we can do, actually, if you want to factorize this, you might actually be able to, because you'll see that 3 plus 2i and you'll see that 3 plus 2i here. So you might be able to take out z squared out of the first, and then you have 3z plus 2i. And then in the second, you have 3z plus 2i. So you can take that as a factor. And so you have 3z plus 2i. And z squared plus 1. Now, to be honest, we actually could have maybe used that to show that 3z plus 2i is a factor instead of plugging it in. But that's okay. So let's just write that as working out. We'll say that, because it says hence or otherwise. So we can say that z squared, p of z, f of z, is equal to z squared, 3z plus 2i, plus 3z plus 2i. And then we can take 3z plus 2i as a common factor, and then we've got z squared plus 1, right? And if we solve, that's equal to 0. We obviously had the, so it says solve the equation, so you still need to give this one here. So you can say that 3z plus 2i is equal to 0, or z is equal to negative 2i on 3, or z squared plus 1 is equal to 0, z squared is equal to negative 1, z is equal to I or negative I. So those are the three solutions. Okay. Then it says plot the solutions. So we had I, negative I, and then negative 2i on 3. Is that right? which is over, so 1, 2, that's 1/3. Sorry, it should be in the negative. That's a bit weird. Yeah. Okay, so I'll just say Z1, Z2, Z3, and Z1 is equal to I, Z2 is equal to negative 2I on 3, Z3 is equal to negative I. Prove that if x is an odd integer, then 2x squared minus 3x minus 7 is even using a direct proof. So if x is odd, then we can say that there exists k, which is an element of integers, such that x is equal to 2k plus 1. So that means 2x squared minus 3x minus 7 is equal to 2 times 2k plus 1 squared minus 3 times 2k plus 1 minus 7. Now this here is 2 times 4k squared plus 4k plus 1 minus 6k minus 3 minus 7, which is 8k squared plus 8k plus 2 minus 6k minus 10, which is 8k squared plus 2k minus 8, and that's even. So you can say that's 2 times 4k squared plus k minus 4, let 4k squared plus 4k minus 4 equal to m. Therefore, I'll just write equal to 2m, where m equals that, and m is an element of integers. Therefore, we can say that x is odd implies 2x squared minus 3x minus 7 is even. Okay. So we've got this here, which is a function equation, and we've got to use partial fractions. All right. So yeah, they've actually given you the partial fractions form, which is nice. So what we can say is, well, they told us that it can be written in that form. So x minus 1 squared over x plus 1 squared is equal to a plus b over x plus 1 plus c over x plus 1 squared. And then what we can do is we can say that x minus 1 squared is equal to, now this a, to have a common denominator of the x plus 1 squared, we need to multiply by x plus 1 squared. And then plus b only needs one more, x plus 1. And then the c just needs that. So that's if I were to write all of this over x plus 1 squared. Now what we can do is plug in some nice numbers. So x is equal to -1. We'll get rid of this and this. And that means you can see here that -2 squared is equal to c. Therefore, c is equal to 4. Now we can't really plug in another nice number. I mean, you can plug in 1. Let's plug in 1. So x is equal to 1. You can see on this side 0 is equal to 4a plus 4b is equal to 0. Right, because 4a plus 2b is equal to 0. and you can cancel 2, so 2a plus b is equal to 0. And then if you plug in maybe just x is equal to 0, then a plus b is equal to 1. So we can solve these simultaneously. If we just subtract the 2a is equal to negative 1. Oh, no, just a is equal to negative 1. Why did I get positive? Why does it say positive? Wait, let me just double check. Oh, there's still the plus c, whoops, in both of the equations. Okay, so in the x is equal to 1, 0 is equal to 2a, oh wait, 4a, sorry, it was the 4a plus 2b is equal to 0, and then plus 4. So 2a plus 2b is equal to negative 2. And then for the next one, it should be a plus b plus 4 is equal to 1. So a plus b should be equal to negative 3. And then if you subtract these, you should get a is equal to 1. Right? A is equal to negative 2 minus 3. Yep. And then you can plug that back in. So 1 plus b is equal to negative 3. B is equal to negative 4. Is that what we wanted? Positive 4 again. What have I done? Oh, no. B is negative 4. Whoops. Yeah. All right. The graph of f has one turning point. Find the coordinates of this turning point. Okay, so we need to differentiate this. Okay. So I'm just trying to think if we should do it as f of x is equal to x plus 1 over x minus 1. Is that it? No, other way around. X minus 1 over x plus 1 all squared, or if we should just differentiate it. I think we should just differentiate it normally using the quotient rule. Okay, so if we were to say that u is equal to x minus 1 squared, then u dash is equal to 2 times x minus 1. If we were to say that v is x plus 1 squared, then v dash is 2 times x plus 1. All right? Now, that means f dash x is equal to this times this minus that all over this squared. And if we solve, that's equal to 0. Oh, sorry, to the power of 4. That goes, and we can take 2 x minus 1, x plus 1 as a common factor. And then what's left is just one more x plus 1 here. And over here, we've got just 1 x minus 1. So, and that works out to be positive 2. So 1 plus 2, and the x's go. So that will be 4 times x minus 1, x plus 1 is equal to 0. So x is equal to 1, or x is equal to negative 1. Now we need to check which one it is that has a turning point. I mean, we've written it in this form. Does that help? Whatever, let's just do the sign test. So if we plug in maybe 0, So 0 here, that will be 2, so f dash of 0. That's 2 times, that's negative, positive, so still negative. Negative minus another number, which is positive. This is positive, by the way. That's negative on the top and on the bottom, so it's less than 0. Now, f dash of, we'll do something, what you can do, wait, it should change. Okay, wait. Let's just try positive, right? So let's just try 2. Okay, so 2 times, that's positive, that's positive. What is it? It's 2 times 1 times 9 minus 2 times 3 times 1 over a positive number. So this is 18, that's positive. I think. Let me just double check. Yeah, 3 squared, and then 2 times 3 times 1. Yeah, that's right. Okay, so that's positive. Therefore, turning point at x is equal to 1. We don't need to check that since they told us that it's only 1, and if we got it, then that's the 1. And so f of 1 is 0. So therefore, 1, 0. All right. Sketch the graph of f of x on the set of axes. Label the asymptotes with their equations. Okay, so we can use this form. So it was 1 plus b, which was negative 4. So 1 minus 4 over x plus 1 plus 4 over x plus 1 squared, was it? Okay, so our only vertical asymptote will be x is equal to negative 1. Now this should actually be, so if we draw, what I'll do is I'll just draw the two functions, and then we can do addition of ordinates. So if I draw this, that's got an asymptote at y is equal to 1. And it's a negative, so it will look like this and this, right? And then this would look like this and this, right? Oh, but it would be making it with the 0 actually. Because the asymptote would be 0. Okay. So what's going to happen here is this is going to be the asymptote, and you're basically adding the truncus to it. So I'll just do it in red. You're going to have something like this. And what you can do is you can draw that asymptote, okay? Now for this side, it's a bit weird. So we've actually got a negative infinity and a positive infinity, but this one's a lot bigger. So let's just see what happens if we plug in like a half. or we can just do the y-intercept for now. So 1 minus 4 plus 4, and that's just 1. So yes, the y-intercept will be 1. Alright. And then let's just see. So this dominates, right? Because it's squared. Actually, it's going to be the denominator squared, so it'll be smaller. Wait, let's just see. So if we plug in a half and it kind of goes this way, then we kind of know where it's going. Whereas if it goes that way, it's the opposite. So 1 minus 4 over a half is, 4 over 1 plus 1 half plus 1 is 4 over 3 over 2, which is 8 on 3, plus 4 on 3 over 2 squared, so that's 9. So this dominates, right? Because that's bigger than that. Okay, so it will go kind of this way. But just keep in mind that it's going to be on this side of the original truncus. Alright. And then what happens here? As it goes here, you'll have the minimum at the 1, 0, isn't it? So 1, 0. And I think you'll go something like this. Oops. And then, see, this is going to 0 and this is going to 1. So together they're going to go back to approaching 1. So I think that other point that we got might have been the inflection point, but that was at -1. What's happening at -1 on our graph? Nothing. Well, that's an asymptote. Okay, well, whatever. Okay, so let me just rub everything out and say that we've got I think that'll do, to be honest. Consider the vectors these. Find the angle between A and B. Okay, so cos theta is equal to the dot product, which is 0, -3, -6 over the magnitude of A, which is square root of 9 plus 9, or 18, times square root 4 plus 1 is 5, plus 4 is 9, so 3 root 18, and that's 3 times 3 root 2, and that's -9 on 9 root 2, or -1 on root 2. Okay, so the angle between cos theta must be obtuse, and that would be what? 3 pi over 4. Find all possible values of n such that the dot product of A and C is equal to the magnitude of the cross product of A and C. Okay, so the dot product of A and C is 3n. Oh wait, no. There's no n on the left-hand side because it's 0. 6 plus 3, so 9. Right? Yeah. 9 is equal to the magnitude of the cross product. Now, what's the cross product formula? Okay, so what I'm just going to do I'm going to say y1, z1, and I'm going to say x2, y2, z2. All right? So, what have we got? We've got y1, z2, so that's 3. And then we've got minus y2, z1, so 2 times 3, which is 6, I. And then plus x2, z1. Now x2 is n, and then z1 is 3, so 3n. And then minus x1, z2. So x1, there's no x1, and that's 0, so 3n j. And then plus x1, there's no x1, and then minus x2, y1. So x2 is n, and y1 is 3, so another 3nk. Negative 3nk. Okay, so 9 is equal to the square root of negative 3 squared is 9 plus 9n squared plus 9n squared. So what we can do is we can take out 9 out of these. Oops. 9 as a 3. So that would be 3 is equal to square root of 1 plus 2n squared. And 9 is equal to 1 plus 2n squared. 8 is equal to 2n squared. N squared is equal to 4. 2. Does it say values? Possible values. Alright, I think that's it. The curve with that equation is rotated about the x-axis to form a solid of revolution that has volume 7 pi over 2 units. So pi times the integral from, it's just k is greater than 2, so 2 to infinity of y squared dx. So I'll just write it. K minus 1 over x squared dx is equal to 7 pi over 2. And then we say that pi times, so we can cancel the pi's. And we've got k squared over 2 minus, whoops, not 2 to infinity. X only goes up to k over 2. Oh, that says k is greater than 2, not k. Whoops. Okay, so 1 to k over 2. All right. So k squared over 2 minus, now this is x to the negative 2, so it will be x, so plus 1 over x. And that's from 1 to k over 2, and that should be equal to 7 over 2. And then that will be k, oh my god, this is just a constant, so that will become k. Okay, so that would be k squared on 2 plus 2 on k minus k minus 1 is equal to 7 over 2. And then what have we got? So what we can do is we can multiply by k the whole way through. So we cancel that. So k cubed on 2. So I'll write k cubed on 2 plus 2 minus k squared plus k is equal to 7 over 2k. You can also, I should have also multiplied by 2k, to be honest. So k cubed plus 4 minus 2k squared plus 2k is equal to 7k. And then, I think I've made a mistake. K cubed minus 2k squared minus 5k plus 4 is equal to 0. So where's my mistake? So just this part here. Why did I say minus 1? It's plus 1. So it'll be minus k. And then minus 2k. And then that will be negative 9k. Alright. The production of a brand of weed trimmer involves 3 stages, stage 1, stage 2, and stage 3, which takes W1 hours, W2 hours, and W3 hours respectively. Here, W1, W2, whatever, are independent random variables which may be assumed to be normally distributed. Assume that stage 2 starts immediately after stage 1 ends, and that stage 3 starts immediately after stage 2 ends. Find the mean and the variance of the total time to produce one weed trimmer. Okay, so E of W1 plus W2 plus W3 is, you just add them, and that will be 2.5, 4.5. And what's the units? Is it minutes? Hours. Okay. And then the variance. You have to square them and add them. So 3 over 10 squared. I'm just going to say 0.09 plus 0.16 plus 0.25 is equal to, what's that? 0.25 plus 0.25 is 0.5 hours. Okay. Find the variance of the total cost to produce. Okay. Variance of the total cost. Oh, okay. So what's actually going on is this is like a multiple. So we want to know the variance of, is it 10 W1 plus 10, plus 20. I think that's right. And so that would actually be 100 times the variance of W1 plus 400 times the variance of W2 plus 225 times the variance of W3. Now 100 times the variance of W1 is 100 times 0.9, which is 0.09, plus 400 times 0.16, So what's that? 64. 16 times 4 is 64. And then, yeah, I think that's right. Plus 225 times 0.25. 2 times a quarter. Does 4 doesn't go into that. Okay, so 4 into 225 is 5, 2, 6, and 1/4. 56.25. Which is 73 plus 56.25, which is 129.25, I think, dollars. Is that right? Hopefully. If a single weed trimmer is produced, find the probability that the time spent at stage 2 will be less than the time spent at stage 1. Time spent at tape. So probability that W1 is less than W2. And that means W1 minus W2 is less than 0. Okay, so we need the variance of W1 minus W2, which is just you add the standard deviations. So that will be 0.3 squared, so 0.09. So that's variance is 0.25 if you add them. So 0.09 plus 0.16. And so the standard deviation is the square root of that, which is 0.5. Because remember, we going backwards, if we square that, square that, we'll get that. Okay. Now the expected value is, you just subtract them again, and that will be negative 0.1. Is that right? Yeah. Oh, whoops. What have I done? No. The means, you just subtract that. So it'll be negative 0.5. Okay, so W1 minus W2 is normally distributed with a mean of negative 0.5 and a standard deviation of 0.5. So we want to know probability that it's less than 0, which is, if we think about it, negative 0.5 is here, and 0 is here, right? So we know that this is one standard. So what we can write is probability that W1 minus W2 is less than 0 is equal to the probability that W1 minus W2 is less than the mean plus 1 standard deviation. All right? And that's what they've given that to us for. So we can say that if we just work that out, that's the probability that, what is that? That is, so if we do this, it's going to be 1 minus this probability over 2. which is 1 minus 0.68 over 2, which is 32 over 2, or 0.16. Is that right? Yeah, I think so. So we want that. These are the same. So you do 1 minus that and divide it by 2. Solve the differential equation with that equation expressing y as a function of x. Okay, so we've got 2y dy is equal to negative x over the square root of x squared plus 1. All right, dx. Yep. Integrate. Now that's y squared is equal to that integral. Now we can do a u sub, but what will happen? Yeah, so let's just do a u sub. Okay, so what we can do is let u be equal to x squared plus 1. Du is 2x dx. So what we need is we need a 2 there. Take the negative out and put a 1/2. So that still makes negative x. So that's equal to negative 1/2 integral of 1, so u to the power of negative 1/2 du, which is negative 1/2. This will be u to the power of 1/2 divided by 1/2, which is multiplied by 2. Plus c. Okay, so therefore y squared is equal to this, which is negative square root of u, which we said was x squared plus 1 plus c. And they told us y of 0 is negative 2. So when x is equal to 0, y is negative 2. Okay. Meaning 4 is equal to the negative square root of 1 plus c. And that means c is equal to 5. So y squared is equal to that's quite weird, the negative square root of x squared plus 1 plus 5. And we need to say y is equal to the positive or negative square root of of the square root of the negative square root x squared plus 1 plus 5. Now, is it plus or minus? It's actually minus, because when it was 0, it was negative 2. So it's the minus square root, since y of 0 is equal to, you can say less than 0. Alright. Let's just double check that this still works in here. So if we plug in 0, that's 1. Square root of 1 is negative. So negative 1 plus 5 is 4. Square root of that is negative 2. Okay. Using implicit differentiation, show that dy dx is equal to negative y over x, given that 2xy is not equal to negative 1. Okay, so 2xy squared plus 2y, so x squared, 2x squared y dy dx plus x plus y, plus y plus dy dx is equal to 0. So what we can say is 2x squared y plus x dy dx is equal to negative y minus 2x y squared. And so dy over dx is equal to negative y plus 2xy squared over x plus 2xy squared. Which is negative. So if we take out, well, what we can do is separate that into two. Negative y over x. No. Okay. 1 plus, so if we take out 1, you get 1 plus 2x y over x, and then you get 1 plus 2. I think that should be, oops, it's x squared y. 2xy, and since, so you can cancel that since 2xy not equal to negative 1, because if that's 0, then you can't cancel. So therefore, dy over dx is equal to negative y over x. Find all the points on the graph where the slope of the tangent is equal to negative 1. So, alright, dy over dx is equal to negative 1. Therefore, negative y over x is equal to negative 1. Therefore, y is equal to x. Alright, so we've got to plug that into here to figure out what values that is. So that means x cubed, sorry, x to the power of 4 plus x squared is equal to 2. And how are we going to solve that? So we can take if you just look at that equation, it just looks like how many solutions should you get? That's this plus this. So you've got 1, you've got negative 1. And I don't think you've got anything else. Let me just double check. So yeah, you've only got this. So if we're solving it, this graph is equal to 2. You've got here, and this doesn't have any x-intercept. So that's the only x-intercept of this graph. And so we've got a graph just looking like that. So these two solutions. Okay, so it should just be the points are 1, 1, and negative 1, negative 1. Is that right? Because y is equal to x, I think. Yeah, so 1 times 1 plus 1 times 1 is 2, and negative 1 times 1 minus, plus negative 1 times negative 1 is also 1. Okay. A car is travelling along a straight flat road. The velocity of the car and its position are measured from the position on the road where x is equal to 0. The velocity are related by that. A speed detection device is positioned to detect the speed of the car as it passes the position x is equal to 0. The speed limit on the road is 40. Speed detection device will be activated if the car is travelling at 10% or more above the speed limit. Determine with evidence whether the speed detection device will be activated. So, it will be activated if the car is travelling at 10% or more above the speed limit. Now the speed limit, as it passes the position x is equal to 0. And now what's the speed when x is equal to 0? 1/600 plus 672 on pi r cos 0. Now what's r cos of 0? It's pi over 2. So that's 1/600 plus 336, which is 1936. That's what v squared is equal to. So the speed now 4 into 1936 is 4 8 4 sorry 2 square root 484, and then 4 into 484 is 121. So that's 4 root 121. Whatever, I think we'll leave it like that. And the speed limit on the road is 40 kilometers per hour. So this needs to be greater than 44, right? Oh wait, root 121 is 11. Yeah. Okay, so it will be activated if the car is traveling at 10% or more above the speed limit. So so times 1.1 is 44. Therefore, speed device will be activated as speed is 10% greater than 40 kilometers per hour. Find the acceleration of the car in kilometers per hour when x is equal to 12. Give your acceleration in the form k pi. So remember, the acceleration is v dv dx, or derivative 1/2 v squared d over dx. To be honest, I'm just going to use the v dv dx. And so that would be, so what's dv dx? I think it'll be easier to use the other one. Just trying to think if see if they put it in the formula sheet. I can't find it, but I'm pretty sure it's d over dx of 1/2 v squared is the acceleration. Yeah. So d over dx of 800 plus 336 over pi arc cos of x on 20. Now that's just 336 on pi times the -1 on square root of 1 minus, wait, we can do 400 minus x squared. The acceleration of the car when x is 12. (336) on pi times -1 on square root of 400 minus 144, which is 336 times -1 on square root. Now that's 256, which is, what's the square root of 256? Is it 16? No. Yeah, it is. 336 times -1, just -336 on 16 pi. So we can just start off with a 4 instead of doing long division. So that's what, 8t4 and then 4 and 21. So is it -21 pi on 4? Kilometers per hour squared. Okay. Oh, wait, just 21, whoops. 21, why did I write that? -21 on pi. Kilometers per hour squared. K is an element of integers. Yeah, okay. Let lines L1 and L2 be defined by those two. If the shortest distance between the two skew lines L1 and L2 is 14 on root 35, find the values of m. So that's pretty mean to ask a distance between skew lines question, because the formula is not in the formula sheet, but I believe it's the magnitude of A2 minus A1 dot D1 cross D2 over cross the magnitude. Okay, so that will be the magnitude of A2 minus A1. So what's A? Okay, so A2 is 2 minus 1 is 2. And then there's no J. So I'm just so I don't make a mistake. And then plus K. So yeah, plus negative K minus M. So minus K minus M. K. Oh, minus 1 minus M. -1 minus M. Okay. And then dot with the cross product of the direction vectors. Now the cross product of the direction vectors is So let's say that this is D2, so this would be x2, y2, z2, and this is going to be x1, y1, z1. So on the top we've got y1, z2, so 2 times 3 is, 2 times 2, which is 4i, minus, 4 minus y2, z1, 3, so that's just 1i. And then we've got plus x2, z1, so x2 is -1 and z1 is 1, so -1, and then minus x1, z2, x1 is 1, z2 is 2, so minus 2, so minus 3j. And then plus x1, y2, so x1 is 1, y2 is 3, and then minus x2, y1, -1 times 1, so plus 1, so 4k over the magnitude of this, which is square root 1 plus 9 is 10 plus 4 plus 16 is 26. And that should be equal to 14 on root 35. Okay, so what's the dot product? Well, that's going to be 2. The 0 goes away, and then plus -1 minus m. So I'll just say 2 minus 4, -1 plus m over root 26 is equal to 14 on root 35. Now that's fine. Now it's just the magnitude of this. Okay, so if we square both sides, actually, if I multiply that over, I don't even think these simplify. Okay, whatever. So, does it say anything? Find the values of m. I feel like I've made a mistake to get the, I feel like it should be a bit nicer. Okay, let me just double check. So y1, z2, 2 and 2 is 4, minus y2, z1, 3 times 1. So that's 1, so that's definitely I. And then plus x2, -1, minus, x2, z1, -1, minus x1, z2, 1 times 2. So that's -3. And then for the last one, it's x1, y2. So x1 is 1, y2 is 3. So plus, x1, y2, 3, minus x2, y1. Is that 5? Okay, let's do that one again. x1, 1 times y2, that's 3, minus, and then x2, y1, -1 times 2. That should be 5. So that's root 25 plus 9 is 34. That's over 6, I think. Because it's 25, yeah. Okay. No. 25 plus 9 is 34, plus 1 is 35. Man, I hate the cross product. Alright, that's a lot better. So we can say that the negative of this, or we can just say 2 minus 4, 1 plus m is equal to 14. So 2 minus 4m is equal to 14. Negative 4m, that's negative 2 there, is equal to 16. M is equal to negative 4. Or 2 minus 4, 1 plus m is equal to negative 14. So negative 2 minus 4m is equal to negative 14. Negative 4m is equal to negative 14 plus 2 is negative 12. M is equal to 3. Okay, I think that's it. So that was the special exam. It was alright. Just like 2 cross products questions killed me. And I probably made a mistake somewhere, but if I did, just let me know in the comments. Okay?